Okay, in this video I'm going to break down how I built the sign behind me. So the way it works in the shop where I'm employed is they hand me the paper with the details and they trust me to basically make it however I want. I've been doing this a long time. I start out with the computer files, but I'm going to skip over that in this video because it's just going to take too long. So I CNC all the parts. This is what's going to be the face. It has 3/16 aluminum with a lip on the outside. It's too big for the CNC to do in one piece, so I have to weld it together. This is just showing the parts, and I have a MDF template. It's about the same size that I'll end up using to tape it down to in a bit. Here I'm just tacking it, and I'll end up flipping it over and welding the whole thing. Once it's welded, I grind and sand it smooth so it's pretty much unnoticeable. You can see here there's pretty much no trace of the weld at all. So this now makes those two pieces into one solid piece. Here I am using double-sided tape to tape it down to this jig that I have that's the same shape. I used this part a few times in the build. I tape it down so when I'm welding it together, it kind of helps hold the shape a little bit better. Those pieces are the trim that I'm going to use on the side. I just sheared them on the shear, which you can actually see through that red material there, the welding screen. And in this, I'm just going to bend it by hand with these in between those two little metal rods that I have, and just take my time and form it to the shape that I need. Most of this flower shape is very loose. There's no real hard corners, so it's relatively easy to bend. The only thing that has the harder radius are the corner or the flower tips, the petal tips. And here it is afterwards. You can see it's a pretty nice tight fit, which will make a good weld. So for this, I just MIG welded it down. You can see I'm just shifting it along using the table edge and a clamp to keep it pressed in and tapped up nice and tight up against where I need it. I just brush it clean, give it a weld, move on to the next spot. I only put little welds on a job like this because if you start adding big welds, it's going to get really distorted real fast. This is the type of job that takes quite a bit of time, but it makes for a very nice final product. Just give it a tap with the hammer to straighten it all out. And you can see here with some sections I've brushed clean. And there's the other parts that I haven't wire brushed yet. A lot of this video I'm kind of just skipping over some parts because there's quite a bit of work involved. So I'm now reusing that wooden flower jig, and I'm actually have it resting on top of the welded piece. What I need to do now is take a 1/4 inch off of the whole thing so I can fit it inside. And see, here it is. I just used a flap disc on an angle grinder, ripped it around pretty quickly, and now you see it fits inside. I will then use this wooden piece as the jig for my acrylic that I need to cut out. Coming steps. You can actually see it in the background there. Before I do that, though, I'm going to clean up the edges on all this shop-made trim cap here, and just give it clean it up. There are some weld divots, but on a sign like this, it's going up 15 feet in the air. After I sand them, you can see here they're pretty much unnoticeable. Just give it a little extra sand on the spots and almost gone. After paint and primer, you wouldn't even see them. So now I have that acrylic piece, which has already been vinyled by someone else, and I just trace out my wooden jig onto it, and then I'm going to start cutting it out. Just going old school here because it's too big for my machine, so we've got a jigsaw. And I have the jigsaw sitting on top of a sheet of 2-inch pink foam. That's what's popping up through the slot afterwards. After I used the jigsaw, I cleaned up all the edges by sanding it nice and smooth and rounding off all the inner corners to prevent cracks. After that, I sanded all the face of the aluminum, just making it. This is for prepping for paint, get the primer to stick. I use a 2-part epoxy primer. That's going to be in a later step. So after sanding, you can see the face is all smooth and the edges are all cleaned up. There's not even really a seam from the weld. Few weld divots every once in a while, but like I said before, after primer, you don't see it. This is the stuff we use for the channel coil for the rest of the body. It comes in long coils, but we send it out to get bent or cut, sheared into 10-foot lengths, and then they bend it along the 10-foot length with a 1/2-inch lip. As you can see, it's white on the inside, black on the outside. Make it a bunch of colors, but we're just using the black. So I bend these letters by hand. I don't have a fancy machine for this, so I go around with a marker and just mark everywhere I think I need to notch out that lip on the aluminum. Just go around the whole thing. On some shapes, it's easier because there's corners or something. This one was very much just a loose placement of where I felt it needed to be bent. So then to transfer this onto that aluminum, I'm using this. It's a butyl type tape, just a flexible plastic, clear. It is the same thickness as the metal. So when you're taking corners, inside or outside corners, the length stays the same. So after I mark it, wipe it, and here I am just notching it. That is a hand notcher that takes a 30-degree notch. Or actually, I think it's a 60-degree notch out of the aluminum lip there. So after I have this little small brake, metal brake with a foot pedal that locks it in place, and I just bent the inner. This is going to work up to three pieces. So there are 3 corners where it has an internal bend. To form it, I just do it by hand. There's no hard corners that need to be broken, so everything is just take your time and bend it. It's pretty thin metal, so not too hard to do. To attach it to the back, I raise it up on some wood blocks and then just drill and rivet. That was the fabrication manager who just came in there for a minute. He's a good guy. Rivets, rivets, rivets. I've probably done 1 million rivets in my lifetime, at least. My elbow feels them now, every day. This does take some time to do. The total size of this sign is 6 feet. So the table, the CNC machine that we have at the shop there is only 5 feet wide. Can't do this big, so everything had to be cut in parts and sections. Like the backer there is just some a widow or 2 millimeter thick aluminum that I cut on the CNC in 2 sections, and I'm just putting it together. Normally I would put a baffle on there and attach it together before I do the assembly, but I wasn't sure how it was going to be mounted at this point to the wall, because it's being mounted on some pipes. So I just left it until I got the information I needed. Ends up being just a simple baffle anyway, no braces. But you can see I got a big pair of shears, and I just cut it to the length that I need after I've notched it all. Just keep riveting. The rivets I'm using to attach the returns are number 42 aluminum rivets. They are 1/8 inch hole size and will crush pretty much 1/8 inch also. Since the backer is 080 and the sides are 040, it adds up to pretty much exactly what I need. I didn't bother counting the rivets in this sign, but there's definitely over 150. So this sign is actually a logo for famous or a well-known Canadian society. If anybody recognizes it, leave a comment as to what you think it is. The company that I'm working for here is donating this, so they told me to make sure it was built properly and highest quality. So after you can see I've riveted, I flipped it over, and as you can see the shape is nice and tight on the inside. Here's what I'm cutting on the CNC. This machine is pretty much always running in the background. Cutting some brackets here for the next step. As you can see, I'm just bending them into 90 degrees. Actually, you can see on the side there that I've already test fit the face to the thing. Sign lock 810. This is the stuff that it's very common in our industry here, sign industry. And it's basically like a two-part JB Weld type product. Glues aluminum really well. Never had any issues when it's used properly. And so I just bent some corners to seal up the joining of the 3 separate aluminum edges, or sorry, the returns. That's what the yellow tape is just holding them on. And then I glued on all those, sign locked on all those brackets on the inside. And now I'm just, after it dried, I believe this is probably the next day, I came back and drilled out the holes as I'm going to attach them with fasteners also. I'm just going to attach the fasteners to the backer, not the sides. So I'm just peeling off my tape and more rivets. This is just going into the riveting into the braces that I added, and then also the baffle. I'm just securing it here. You can see I'm just widening up the holes to make the rivets go in a little easier, and just popping them in. The rivets I'm using here are actually a little bit bigger. They're number 64s. They go into a 3/16 hole. The sign's pretty stiff once it's like this already, but I got to seal it up. So this is just window and door caulking, latex caulking, and just go around the edge to help keep water from just dripping directly in. And just smear it nice and thick with my finger, and it's just water based, so it just washes off nice and easy. I don't really like using silicone for that. So to attach the face, I have to make some brackets. They'll be pretty much floating on top of these brackets. So I'm just cutting them and bending them into shape myself. This little break we have is definitely not meant to bend this 1/8 material, but I welded some legs on the side to clamp it to the table, and I just use a pull for extra leverage, and it does it. It's been doing it for years just fine. So these things, I'm just putting a 90-degree bend on them, and then I'm going to cut them to the right height that I need. Trim them down to the right height, just on the table saw here. After that, I got to take them over, deburr them a bit on the little sander because I'm going to be handling them and I don't feel like getting cut. And I got to cut them into little 1-inch strips. There's 6 petals on this flower, and I use 4 strips per petal. So 24 strips total here. Then we're going back to the sander to clean them up again. A lot of little steps in making a sign like this. I drill these things so that way when I sign lock them onto the side, it lets some of the sign lock ooze out. Just something I've learned over the years helps keep it in place. Similar to sanding up or scuffing up the back. This just is a little faster. After I drill the holes, I actually used an old dull bit, so there's quite a bit of burrs on it. So I just use a countersink bit here and I just clean it up. More sign lock. Just gonna put them on and I just press them in place. Stuff takes about half an hour to harden enough that you can continue on with the job. What's good about this too is there's no visible fasteners on the outside. This up next, I'm going to start painting while that sign lock hardens. So I got the aluminum trim cap in the face, the retainer that we're going to use here, and I'm just using a 2-part epoxy primer. A lot of places would use a acid etch type primer, but I'm not a fan of it, and the smell drives me crazy. From the thumbnail for this video, you can see that the sign is this yellow color. It's a Pantone 109C, which is like a bright yellow. Well, and the problem with painting yellow, I always hate painting yellow because it just takes so many coats. So after I get the color mixed up, I mixed up enough to do a bunch of coats. If this was a blue or something, I would have just mixed a little bit and been done with it. But with this yellow, it's very thin. So after spraying, I go around, or before I spray, I go around and check for dust, make sure it's all good. Just knock off any dusty spots, and then go around and spray this yellow on. I only show me spraying 1 coat on camera here, but I actually had to spray 6 coats, 2 coats per day for 3 days. And I still feel like at the end I probably could have done more, but it's not a car and you can't tell. I mean, the paint here you can see looks good, but it's far too blue of a color at this point. The more coats I add to it, the warmer it starts to get. Just because the tendency of yellow paint. Here I'm just using some 3-diode LED modules. I just spaced them out. I believe it worked out to a total of about 70 watts. 72 or 70 watts. 70 or 72 watts, something like that. When I was done. These LEDs are 6,000 kelvins, so they're nice, bright, cool white instead of a warm color. So where I'm located, all the LED signs have to be done with Class 2 drivers. Class 2 drivers are limited on how much power each driver or channel of the driver can put out. So what I have here is a 2-channel driver. And each channel can put out a maximum of 5 amps, or in this case, it's about 60 watts, right? So I need 2 channels, and I kind of divide them relatively easily, or relatively evenly amongst the 2 of them, but it doesn't really matter. One of the things I have learned to do with these long strings of diodes is connect both ends. So I actually connect a positive on one side of the cable and a positive on the other side back to the driver, positive and negative. I run them both back to the driver. If you don't, you end up getting voltage droop, and you can see that one side is dimmer than the other. For some types of LEDs, I'll even add power injection in the middle. You know, cut them to shorter things and add more power. I'm just about done the electrical here and about to power it up. After that, I made sure all the wires were glued down and it was electrically bonded. Added a switch and wired it up temporarily to test it out. We have these signs electrically tested by a third-party company to be certified, and so we just follow all the steps. Here I'm just adding some silicone to the side of the LEDs because in the cold temperatures sometimes they have the tendency to fall off, and this just prevents that. Here I've got the sign face sitting on top of those angles that we bent, just positioning it in the right spot before I screw it down. Screwing it down is a 4-step process. I start off with a pilot hole bit and drill right through both the acrylic and the metal. Then I tap both of them as well with an 832 tap. After that I countersink the acrylic so we can sink the screw down inside. Then I use a 3/16 bit as a clearance hole. Once we do that, we put the screw in, and only 23 more to go. After that, I fit the retainer on and put it in with some self-tapper screws. Here it is fully assembled and powered on, ready to go for installation. This company has an installation crew, so it'll be done by them. I'll take you down afterwards. Here I am on location of the installation, and this is what it looks like when it's done. I'd be really surprised if anyone made it through this whole video, so if you did, leave a comment or give me a like. It would be much appreciated. Thanks for watching.